Good morning, children. Today in this class we are discussing about combination of resistors in parallel. When resistors are connected in parallel, what happens to the total resistance, how to calculate the total resistance, then what is the voltage along each resistor, that you know in brief, that we are going to discuss. When resistors are connected in parallel, the reciprocal of combined resistance is equal to sum of the reciprocals of individual resistors. That means 1 by R equal to 1 by R1 plus 1 by R2 etc. goes on 1 by R3, 1 by 1 by R4 etc. When resistors are connected in parallel, voltage along each resistor remains same and current along each resistor varies as in the figure. There are two figures, just observe them. In both the cases, resistances are connected in parallel. Now we shall now go on discussing how to calculate the current along each resistor, how to calculate the total voltage, how to calculate when the resistance one or the other resistance is not given. So these all things will be discussed in further slides. Especially there is one more slide, the second slide. There combination of resistors in parallel is explained once more. So you go through that. So later we will be solving problems based on combination of resistors in parallel.
Resistors in parallel. Now let us see the parallel arrangement of resistors. Take three resistors, say R1, R2 and R3, and ammeter, voltmeter, battery, plug key. Connect three resistors R1, R2 and R3 in parallel to each other in the circuit with battery, plug key and ammeter. Connect voltmeter in parallel with a combination of resistors. Plug the key and note the ammeter reading I and voltmeter reading V. Take out the plug from the key. Remove the ammeter and voltmeter from the circuit. Connect the voltmeter across each resistor and insert the ammeter in series with the resistor R1. Note the ammeter reading I1. Similarly, connect voltmeter and ammeter with other two resistors I2 and I3. We can see that the total current in the circuit I is equals to sum of currents I1, I2 and I3 through resistors. By applying the Ohm's law to the parallel combination of resistors, we have I equals to V by Rp. Now applying the Ohm's law to each resistor, we have I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Substituting 1, 2, 3 and 4 in B, we get V by Rp is equal to V by R1 plus V by R2 plus V by R3, or 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. We may conclude that the reciprocal of resistance Rp is equals to sum of the reciprocals of individual resistances.
In this slide, we are trying to discuss an example to calculate total resistance when resistors are connected in parallel. In the given figure, try to find out total resistance, current along each resistor. Solution: given V equal to 9 volt, resistance R1 has taken as 10 ohm, R2 taken as 2 ohm and R3 is 1 ohm. Everywhere apply Ohm's law. Later, first try to find the total resistance. 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by R equal to 1 by 10 plus 1 by 2 plus 1 by 1. Take LCM for denominator and simplify. You get 1 by R equal to 16 by 10. R equal to, on reversing, you get 10 by 16 ohm. This is the total resistance of the circuit. Now try to find current along each resistor. Current along each resistor equal to I1 equal to V by R1, I2 equal to V by R2, I3 equal to V by R3. So current along each resistor has been calculated here, and total current you can calculate as 14.4 ampere you get. So that is the total current flowing through the circuit. Total resistance you know, total current you know. Then you can also calculate V equal to IR formula you can put, or I equal to V by R you can put and calculate total current. There also you will get current as 14.4 amperes. That means when these resistors are connected in parallel, each resistor is getting equal voltage, but current along each resistor is differing depending on the resistance. So here is a summary about combination of resistors in parallel. When resistors are connected in parallel, total current along the circuit is the sum of individual current along each resistors. Reciprocal of combined resistance is the sum of reciprocals of individual resistors connected in parallel. 1 by R equal to 1 by R1 plus 1 by R2 plus R3 etc. When resistors are connected in parallel, every appliance or every resistor will get equal voltage. So parallel combination is preferred in domestic circuits. Just here is a slide, or here you can remember what are the important concepts based on parallel connection. Parallel connection, voltage throughout circuit remains same, voltage along each resistor remains same, total current equal to I1 plus I2 plus I3. It is fit for domestic circuits. Total resistance is less than individual resistance. All appliances are connected to different circuit. So this is what you are supposed to remember overall in a gist for parallel combination.